Math 70, section 6.4. This is factoring special products. This is my favorite section of factoring. These are pretty easy types of factoring. You just got to get used to what to look for. Okay, so section 6.4. We've got our first item is factoring perfect square trinomials. Okay, so these are some things that you need to look for. So in example 1, z squared plus 6z plus 9. When you have a trinomial, there's 3 terms here. If the first term is a perfect square and the last term is a perfect square, we talked about perfect squares. So 9 is a perfect square because 3 times 3 is 9. And there must be a plus sign right here. Okay, so the first and the last have to be perfect squares. And if you take one of each of these and multiply them together and by the number 2, so 2 times 3 times z, if you get this middle term, this will factor to be z, one of each of these, and one of each of these, and whatever this sign is, they will both be the same. I call these twins. So this will factor out to be z plus 3 quantity squared. Okay, let's look at a couple of these. So the next one is number 2. We've got two, we have a and b. So again, we have a trinomial 4x squared minus 20x plus 25. So the first term I notice is a perfect square. 2x times 2x is 4x squared. This, always make sure this is a plus sign. 5 times 5 is 25. If this were a minus, you can't do what I'm about to do. Okay, so if you multiply one of each of these times the number 2, so 2x times 5 times 2, that gives you 20x. As long as it gives you that middle term, what you have here, you're going to take the first term and the last one, and whatever sign this is, they'll be identical. So this is 2x minus 5 quantity squared. For b, 9x squared is 3x times 3x, and 49y squared is 7y times 7y. If the product of one of each of these, 21xy times 2, gives you that middle term, which it does, then you have 3x plus 7y, 3x plus 7y, or 3x plus 7y squared. Okay. Another one, example 3. We've got b squared. So b times b is b squared. 6 times 6 is 36. Now when I multiply one of each of these times the number 2, I don't get 12. So I have a 10 here. I get 12. I'm sorry. I get 12, but this is a negative 10. So this is not a perfect square trinomial. This is a not guess and check, but what times what is b squared? What times what is 36? But adds to be negative 10. So we have 9 and 4. That's not going to give you negative 10. We've got 6 and 6. That's not going to give you negative 10. We've got 2 and 18. Nope. So it looks like example 3 is prime. Looks like we cannot, we cannot, it's prime. So we can't factor that. Okay. So what do we do on example 4? We're going to pull out the GCF. The greatest common factor, I'm going to say is, looks like we could take a 2 out of these terms. So if I took a 2 out, I get 16m to the 4th minus 24m squared plus 9. So now this alerts me to the fact 4m squared times 4m squared is 16m to the fourth, and 3 times 3 is 9, and there's a plus sign there. So if I take one of each of these and multiply it by 2, I do get negative 24m squared, because 4m squared times 3 is 12m squared times 2 is 24m squared. So now this factors to be 2, 4m squared minus 3, 4m squared minus 3. Or I can abbreviate it, quantity squared. Okay? The next one is called the difference of two perfect squares. Okay? The difference of two perfect squares. So what do you do when you have only two terms and a minus sign in between them? It has to be two terms, a minus sign in between, but both terms are perfect squares. So n squared minus 81. So if you have just two terms, they're both perfect squares. 9 times 9 is 81. If there's a minus sign in between, this will factor to look like this. N, 9, 9. But in the last case, it was whatever that middle sign was. These are going to be opposites. Now, why are they opposites? Because when you go to FOIL this out, n times n is n squared, and then we have a plus 9n, negative 9n, and negative 81. These two cancel out. So the way to get them to cancel out is when one is positive, one is negative. Now this answer could have been written n plus 9, n minus 9. Doesn't matter where the plus or the minus go, but you have to have one of each. So again, when the first term is a perfect square and the second term is a perfect square and there's a minus sign, that's how you will break it up. So those are pretty easy. For this one, you've got 16x squared. So 4x times 4x, and 9y is 3y, 3y. So this is 4x minus 3y, 4x plus 3y. Okay? Very simple. For number, for the next one, what you're going to notice here is this is 49k to the fourth is 7k squared times 7k squared. 100 is 10 times 10. So this is 7k squared minus 10. 7k squared plus 10. Next one, p squared times p squared, and 1 times 1 is 1. So this is p squared minus 1, p squared plus 1. Now you'll notice that this piece can also be broken down into p minus 1, p plus 1. So this is also the difference of two perfect squares. P times p is p squared, 1 times 1 is 1, and you have a negative. Now this one can't be broken down because that's a plus sign. Remember, there has to be a minus sign in between. Okay, and what happens when you have two terms, but it looks like you might be able to factor out a GCF? You always want to try that out. So it looks like I could take a 2 out of both of these. If I take a 2 out, I'm left with 25x squared and 36y squared. Now this is a perfect square, 5x times 5x, and this is 6y times 6y. So we're going to bring down the 2, 5x minus 6y times 5x plus 6y. Okay? Okay, last one last type of factoring. These are a little tricky, but you just have to practice them. This is how to factor the sum or difference of two perfect cubes. Now, what is a perfect cube? A cube is a number like 1 times 1 times 1 is 1. 1's a perfect cube. 2 times 2 times 2 is 8. 8's a perfect cube. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. Let's do 10, 10, 10, 1,000. So look for these numbers, and also variables like x cubed, x to the 6th power. Anything that you can break up into 3 equal parts is a perfect cube. So now what you do, this is how it's going to go. We have example 8 and 9. And so how do you factor the sum or difference? Now for these ones, for cubes, the middle term, you're going to have two terms, but you could have a plus or a minus sign in between, whereas the difference of two perfect squares had to be a minus. Okay, so this is how it goes. Okay, so what 3 terms multiply to give you x cubed? XXX. What 3 multiply to give you 8? 2, 2, 2. So this is how it looks. You're going to have a binomial and a trinomial. In the binomial, you're going to have, excuse me, one of each of these goes in this binomial, and whatever this sign is will be that sign. Then over here, you're going to have a trinomial. These two get multiplied, goes right here. Whatever this sign is, switch it. Multiply each of these together, x times 2, which is 2x. And this sign will always be a positive no matter what. 2 times 2 is 4. So here we go. The first one of each of these goes in here. Then multiply this together, you get that term. And multiply one of each of these to get the middle, and then the last two go here. Remember, this is always a plus sign. Okay, this always that sign, and this is always the opposite of what it started with. So if this were x cubed plus 8, this would have been x plus 2, x squared minus 2x, and plus 4. Okay, so let's do another one of these. So we've got 8m to the 3rd plus 125n to the 6th. So we want to know what 3, 2m times 2m times 2m, and this would be 5n squared, 5n squared, 5n squared. These 3 multiply to give you that. These 3 multiply to give you that. So you're going to have a binomial, one of each of these. So 2m, whatever this sign is, 5n squared. Then these two get multiplied together to go here. This is 4m squared. Switch the sign. Multiply these two together. So that's 10mn squared. And then the last is always a positive. Multiply these two together. 25n to the 4th. Okay? And the last one, always look to see, can you take something out? Looks like we can take out a 2x. So if I take out a 2x, this would be 125x cubed and then plus 27. So this would be 5x, 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 3, 3, 3. So we're going to have a by and then a try. So one of each of these, so 5x and a 3 go here with the plus sign. Then multiply these two, 25x squared, switch the sign, multiply these two, 15x, always a plus sign, 3 times 3 is 9. We are done with section 6.4.